The power generation in India has grown 100-folds since independence. With a production of 1006 terawatt-hours, India is the 5th largest producer and consumer of electricity in the world. In the past decade, the power sector grew by 7.5% and the annual electricity generation by 5.5%. Power is considered to be a core industry as it facilitates development across various sectors of the Indian economy. The liberalization of the power industry has seen active investment from the private sector and also introduction of modern technologies and integrated transmission systems.
Hello and welcome to Answers for India's Progress, brought to you in association with Siemens. I'm Varun Kumar and today we focus on the energy and power sector. Now, through this series, we have been focusing on how various industries have benefited through Siemens' cutting-edge technology. In today's episode, we focus on yet another interesting aspect of the company, on how Siemens not only provided technology, but also infrastructure to address the increasing demand of power in the country.
India's rapid growth over the past 2 decades has drastically increased demand for power. The industry experts expect the total primary energy demand to double by the year 2030. But inconsistent power supply imposes a heavy burden on fast-growing trade and industry. This is where Siemens is trying to revolutionize the existing power system by providing flexible and effective technical solutions such as high-voltage direct current or HVDC transmission systems.
Siemens as overall in the energy sector is present in the entire value chain of the energy. Right from the exploration, be it the oil wells in the upstream, midstream, downstream, in the automation systems of the explorations in minings, and then we come down into the core generation, which could be either a fossil generation or oil-fired, gas-fired plants or the nuclear. Presently we are a little bit subdued, and even the renewable energies in terms of wind. So we are actively participating in the various modes of the power generation.
One of the companies benefiting from Siemens technologies is Adani Power, the largest private thermal power producer in India, with power capacity of 7,300 megawatts.
Adani Power Limited and Siemens came together to transmit high-voltage direct current from the western grid to the northern grid. This huge undertaking was made possible by Siemens' technology and infrastructure that ensured minimum loss of power transmitted over long distances. In fact, Adani has been constantly depending on technology for better results. Here's a look at Adani's journey in India so far.
Adani Power was started as a power trading company in 1996. The company started power generation in July 2009 by implementation of its first 330 megawatt at Mundra Super Mega project, which is also the largest coal-based project of India and the 5th largest in the world. Adani is currently implementing 16,500 megawatts at different stages of planning and operation, and its mission is to achieve 20,000 megawatts power by 2020.
Adani Group since long was in a business of coal. They are also in the port and they were also in the power trading. So it was obvious for them to decide and take a step to enter in the generation. Once they enter in the generation, they also thought of the transmission system so that they become more competitive in their bidding of the power trading. In a step, they were already doing something with the AC system, but then they decided to enter in the HVDC. In the current scenario, the proven technology of HVDC, if power is transferred on a longer distance and the high quantum, is quite cheaper as well as it's quite reliable. So that is why the decision was taken on this. However, the conventional AC system is well known to everybody and it is proven. But in this particular case, because of the more distance, it was taken a conscious decision to go for the HVDC.
HVDC technology is the adequate solution for economical transmission over a very long distance and the only realistic alternative to alternate current technology. Adani's Mundra Mohindergarh HVDC transmission system is the first private sector HVDC project in the country with 989 kilometers long transmission lines. This line can transmit bulk power with low loss and carries affordable electricity from Mundra, Gujarat to Mohindergarh in Haryana.
Now to talk to us more about how high voltage direct current is transmitted from Mundra to Mohindergarh, we are joined on the show by Mr. D.P. Tripathi, who is the Senior Vice President at Adani Power Limited. Mr. Tripathi, thank you very much for joining us on the show. Mr. Tripathi, if you could tell me a little bit about how this process of transmission takes place and what is it that you're doing at this particular terminal?
Varun, HVDC, any HVDC has basic three parts. One is the rectifier, from where AC to DC is converted. Other is the transmission line, which carries the DC power from the rectifier to the inverter. And the third part is the inverter station, from where the power from DC form is converted into AC form. Now coming to this station, any rectifier or inverter station, we call it a converter station. A converter station has three basic parts again. The first is the DC switchyard here that we see. Other is the AC switchyard on the other side. And in the between you have the two parts. One is called the thyristor valve hall, which converts from DC to AC or AC to DC, and a control system, which is a complex system. The power from Mundra is coming on that transmission line that you are seeing, the one with the peak. From there, it is below here is a switchyard, which does the change of mode of operation. There are many modes of operation, like monopolar and bipolar mode. From there, it goes into the valve hall. You can see there you can see the filters, both sides. These filters, what they do is to filter out the jitters in the DC, so that what the DC enters into the valve hall is a smooth one. The most interesting part of HVDC station, this is the control room, where the power is controlled. The operator is able to control the power to a very precise level of 1 megawatt. The change of power can be done from a 1 megawatt per minute to a very rapid of 300 megawatt per minute. The control system here is so designed to help northern and western grid stability of power. In case of any emergency, the controller takes over and modulates its power in such a manner that the grid stability is maintained. This part is you can call as the heart of the station. It consists of thyristor valves, which converts from DC to AC. These are the fast switches. Really, these switches, they rapidly switch on and switch off to convert from DC to AC. These thyristors are cooled using the demineralized water. This demineralized water is again cooled using the evaporative cooling towers. On the left side, you can see the bushing from the converter transformer, where the AC output is going out to the network. The complete valve hall is surrounded into using aluminum cladding to prevent radio noises from escaping out. The environment inside is maintained slightly pressurized to avoid dust coming inside. This is the prefabricated valve hall building. This is the only valve hall which is made by prefabricated building. There are all other valve halls are made by conventional type of brick, the concrete structure. Then in front of that, what you see is the converter transformer. These converter transformers are indigenously made by Siemens in India, and these are the biggest HVDC transformers made in India. Here, to filter out the jitters, we have the filters here. It smooths the AC waveform before it goes to the consumer's end.
The Gujarat-Haryana HVDC transmission system might be a success story for Siemens and Adani Power, but they had to face a lot of challenges for this setup.
From the challenge point of view, we had initially done such type of jobs. There was a hesitation whether a private entrepreneur would be able to take that step or not, and how do we enable them to then take it forward, not only in setting up the plant but also in continuing to maintain and running it. So in this whole course of execution, it is not merely setting up of the whole plant but training of the people, carrying forward their abilities to be able to handle this plant in subsequent way. And I would say this whole experience went very well because we found quite enterprising people from Adani coming forward and also taking this step. So I would say it was like a bold step coming together and removing the hesitation with the help of trust which we had between two organizations.
Time to slip into a quick break right now, but coming up, we talk to the CEO of Adani Power Limited to find out how Siemens is helping the company bring about a revolution in the power and energy sector. Stay with us.